Before we dive into algebra, let me show you why real numbers and absolute value matter far beyond the classroom. Every GPS calculation you rely on, every thermostat keeping your home comfortable, and every precision main product in manufacturing depends on math. We are about to learn. Today, we're breaking down the real number system, natural, whole, integers, rational, and uncovering how absolute value represents distance, the foundation for tolerance, error margins, and real-world problem solving. If you want math that finally makes sense, stay with me. This will change how you see numbers.
Well, my name is Mahmoud Kiasari and welcome to the first chapter of Advanced Algebra. As you guys know, with the previous some kind of playlist, we were talking about the basic things that are related to algebra that you can see the link on the top of this screen. And right now we decided why not move forward and talk about some advanced things. Everything is continuous part of the previous section, but right now we are going to talk a little bit about advanced. So the very first chapter would be about the real number system and absolute value, which we were talking about it, part of it, as the very first section of the Algebra 101. And right now we are trying to talk a little bit more that what does it actually mean, again review a couple of parts, and at the end solve some example to make sure that you guys completely understand it. So let's get started. So first of all, why it matters for us or any other kind of engineers or any other kind of science section to know about numbers and especially the absolute values. Well, obviously, you know that when we are talking about the GPS and navigation, the distance calculation are so important. When we're talking about the temperature control, it's also important that our temperature should be within the range because we cannot get all of the right and precise value all the time, about the manufacturing parts smart fit, and so on and so forth. So today's goal is that we are trying to connect number lines to equation and master real-world problem solving. At the end of this chapter, I somehow expect you guys to completely understand the difference between the numbers. As you all know, we were talking about it a little bit, that numbers are going to fit inside different categories. So I'm going to review that part again today. And after that, we are trying to master the inequality. Again, we were talking about inequality, but we didn't actually somehow went inside the details that what would happen if we do have this combination with absolute numbers. So don't worry about it, we will talk about that one. After that, we are trying to understand the absolute number, which is the main and some kind of essence of this chapter. And after that, we are going to solve the absolute values equations, absolute of ax plus b is equals to c. We were talking about the equations, one-step and two-step equations in the previous video, Algebra 101. But we didn't talk about that, what would happen if we do have absolute some kind of thing inside of that. So it is important. After that, we are trying to apply this absolute thing into real world problem and see that we are learning something. Do we actually going to use that or just have fun, right? So very first thing, as you guys know, when we are talking about numbers, obviously we don't have one specific type of numbers. We do have 1, 2, 3, -2, we do have fractions, we do have some kind of square roots, we do have radicals, and we do have some numbers that actually, they don't mean anything, but we are going to use them, by the way. But at this point, we are going to talk about different categories that we have and just give you a couple of examples and make sure that you guys completely understand it, because all of the parts, when we are talking about algebra, it's the science related to numbers. So very first thing is that we know which number belongs to which category, right? So the very first category is about the natural numbers. So what are the natural numbers? Simple. You have 1, 2, 3, 4 to the positive infinite, and you see there is no decimal point, there is no zero, and there is no some kind of nonsense wise over here. The only thing that you have are positive numbers. So that's why we call the natural numbers. Another number that if you add 0 beside of that, it means instead of to start from 1, 2, 3, 4, you will start from 0. We do have it as a whole number. So the symbol of whole number is W. I mean, it's completely obvious because of the W and the very first word of whole. And for the natural numbers, we do have n with the first word of n natural. After that, we do have integers, or we call it as z. So what does that mean? It means that rather than just having positive numbers besides 0, we are also going to have negative numbers. It means that my counting would start from negative infinite, for example, -2, -3, whatever, contains 0, also positive numbers. So we can say that actually the natural numbers and whole numbers are going to be inside the category of some kind of the z or integers. So we can say every natural and whole number can be considered as integer, but every integer number not necessarily can be considered as whole or natural number. After that, we do have rational numbers. That's q. So what are the rational numbers? Rational numbers actually contains the z or integral alongside with decimals and fractions. So we do have negative 5.2 or negative 5 over 2 and so on and so forth. After that, we do have irrational numbers. So what are those numbers? There's sometimes that we do have some numbers that actually exist, but they're not going to be ended or not going to be finished at all. For instance, root of 2. If you just use it in your calculator, root 2 is a number, 1 point and some kind of decimal numbers beside of that. But it doesn't necessarily mean that root 2 is just root 4, because root 4 is just 2. Done. There is no decimal, there's no problem. Or like other numbers, we do have, for example, 2.65, and that's it. No, root 2 is a number that actually doesn't end. So this time we just call it as some kind of irrational numbers, and we show it as q. The example would be pi, that we had it for the circles. We do have something called as an Euler number that we are not very familiar right now, and we are going to talk about it in the future, and so on and so forth. So far, we understand that we do have 5 different categories, and the 6th one is a very important one, is a real number. Real number is the one that contains all of those categories together. It means that it has rational and irrational. What is the rational number? Rational numbers are all those top 4 categories, and irrational one at the bottom. So the combination of rational and irrational would be our real number itself. So when we're talking about examples, we can see that over here, that for instance, I do have number 7, and I would ask you to classify this. So as you can see, there is not only going to be one category that 7 can fit in, because 7 is a positive number, no decimal, so it's obviously going to be a natural number, and also it's going to contain a whole number, because yes, it's bigger than 0, and it also can be inside the integer number, yes, because we know the integer numbers means that all of the positive and negative without the decimal. It also can be inside the rational numbers, which is the q1, and after that it also can be real, but the only category that this guy doesn't fit is irrational. What about 0? 0 can be inside the whole, integer, rational, and real. What about negative 3, 2 over 3, so root of 9, root of 2, which we were talking about, it is an irrational one, and that's it. So let's talk about the real section and real part of this subject, this chapter, which is about the absolute. So as you all know, absolute of any number is positive. The absolute of negative 3 is positive. Absolute of positive number is obviously a positive. But what does it actually mean? Absolute means the distance of that specific number to 0 when we are talking about the graphing line. It means that we do have a line that would start from negative infinite to positive infinite, and when we are talking about absolute, it means that 0 is going to be in the middle as a reference, and whatever distance that the specific number has with the 0, we are going to count it and say that this is the absolute of specific number. That's why when we are talking about the distance, all the time the answer is positive. So there is no difference between absolute of 3 and absolute of negative 3. Yes, when you're trying to find those numbers, one is positive 3, one is negative 3. But when we're talking about absolute, both of them are going to be the same itself. So let's see some kind of visualization in order to completely understand what is going on around here. As you can see over here, I do have some kind of the number line. Again, it's about inequality, but I'm going to talk about the absolute number right now. After that, we will talk about inequality itself. So I do have this graph, and this graph is the number line. So I would start from negative 3 to positive 5 itself, and each of these units are going to help me in order to find the distance. For instance, when I'm talking about absolute of 5, actually I'm talking about the distance between this point and 0 itself. I would like to know how much is that. So if I do have the absolute of 3, it's going to be 3. Absolute of negative 3 is going to be 3 as well. So it means that the distance of this guy to 0 is the same as this guy to the 0 itself. So what does it mean when we're talking about inequality? Obviously, you guys know about that. When a number or a specific variable, so what was the variable? Variable was a known thing that we have some clues about it, and we are trying to find that specific number or specific range. But right now, we don't know anything about it. So we have X, Y, Z, A, B, C, whatever you have in your mind, just letters. So inequality means that one specific thing is smaller than a number. So when we do have our first symbol, this guy means that this specific thing, for example, when you're talking about x, that x is going to be smaller than whatever we do have on another side. So all numbers less than number 5 are going to fit inside this category. Another thing that we have is smaller than or equal. So it means that, unlike the previous one, that the only numbers that are going to be contained inside this category should be smaller than 5. This section, we are going to have all of the numbers as smaller than 5 and also equals to 5 itself. So we do have some kind of same parts, but on another side, bigger. It means that whatever number is going to be bigger than specific thing on the right itself. So for instance, when we are talking about y is going to be bigger than -2, all numbers greater than -2. And when we are talking about greater than or equal, same, but at this point, the number can also be equal to -2 itself. And if we would like to show you on the number line itself, you can see that we do have over here. But one important thing at this part is that at some point you see that the numbers or some kind of a graphing that we are trying to show at some point have circle and at some point have this circle. So if our circle is like this, we are going to call it as exclude. So it means that one or the specific number that we would start our work with is not contained inside the specific category. So at this point you see that x is going to be smaller than 5. Whatever number smaller than 5, not equal to 5, the smaller than 5 is going to fit inside this category itself. Y is bigger than or small, y is going to be bigger or equal to -2. Whatever category is bigger than or equals to -2 is going to fit inside this place itself. So that was the definition of some kind of inequality symbols and how we can show it or visualize it. Another thing that we have is about the interval notation basics. Because at some point we are going to have a range, or we are going to have a number that is going to be only between two parts rather than just going to smaller or bigger than. What does that mean? Let me give you some kind of simple example. Imagine that I do have number 2 and I would like to ask you to give me a range that this number 2 is going to be there. So obviously you would say that 2 can be between 1 and 3, right? So how we can actually show that? Simple. I do have number 2. This 2 is going to be bigger than 1 and is going to be smaller than 3. But we don't have numbers all the time. We do have specific 2. At some points we do have a variable. We do have a range, because at those points we can actually, instead of just having only one number, we can talk about a bunch of numbers. So at this point we are going to use the interval notation basics. But how actually we can interpret that? Let's just see some kind of sections or examples related to that. When we are talking about the open interval, it means that that specific range is going to be between the two numbers, while we excluded all of those both numbers again. So when we are talking about the open intervals, means that specific range is going to be between two numbers, a and b, while we know that a and b are going to be excluded, not included. It means that for this example, when you have x is between 2 and 5, x could be any number rather than the 2 and 5 itself. If you remember that, it was just like this circle that we had it over here. It would be open circle between whatever is there. After that, we do have the closed interval. It means that my number is between two numbers, or the range that I'm going to consider between two numbers, and also can be contained of those two specific numbers. For example, when we do have x is going to be between -1 and 3, I know for a fact that my number can be anything between -1 and 3, and also can include these two numbers as well, that we do have something as the closed circle itself. Also, we do have half open intervals. It means that at some point, or at one way, it cannot include that a specific thing or a specific number. Like this point, x is going to be bigger than 0, bigger than equal. And also x is going to be smaller than or equal to number 4. So it means that this guy is include, this guy is exclude. And also we do have infinite intervals. It was the one thing that actually we were talking about it. So when we are saying that x is bigger than 2, it can be all of the numbers from 2. Again, 2 is excluded because of this sign. And all of the numbers from 2 to positive infinite itself. And when we are talking about this one, again, same scenario, but with this difference, that -1 is going to be included. And if someone asks you to show the visualization, you do have something like this. The open interval, the number between 2 and 5 is going to be like that one. As you can see, we do have open circle. If we do have the closed interval, we do have circle, but this guy are filled or closed. If we do have half open interval, it means that this number is going to be excluded and this number is included. And after that, when we do have some kind of another part, for instance, when we are talking about what everything x bigger than or equal to 1, we are talking about this one. This is excluded and everything after that. So let's some kind of talk about setting a builder and graphing intervals. So as I just told you on that part, we only have, for example, it's between to a specific number bigger than or smaller than something. But at some point, we are going to have some conditions for the numbers itself rather than just showing it like the previous part. We are going to have another way of showing a specific range or number itself. So at this point, we do have something like this that we call it as set builder notation. It means that I do have some kind of x, after that a line, and I do have my condition itself. How we can read it? The set of all x such that condition is true. It means that right now I only can contain the x's or whatever variable that I have that's going to satisfy that specific condition, which is going to be after the line itself. For instance, when I'm talking about my range or when I'm talking about the x, I only need the x's that are going to be bigger than or equal to number 4. So all x greater than or equal to number 4 itself. Another one is, let's see some examples about that just. So at this point, I do have some kind of this section. So at this point, I do have, we were talking about the setting a builder, but maybe some of you would say that I really like the previous way. I don't like to some kind of have the condition that which both of them are true. So how can convert that one to intervals? Simple. So at this point, if I do have my x and the condition should be satisfied by x is bigger than or equal to number 4, I can convert it to this one. So I do have this one. This guy is included and this guy is open because obviously we don't know what is a positive infinite. If I do have this one, we can some kind of convert it to that. And if I do have a range of numbers, I can convert it to this one itself. So let's see an example. I do have an example and I know for a fact I'm looking for a range or I'm looking for a number that's going to be between -2 and 3 by knowing the fact that this guy is excluded and this guy is included itself. So open circle again means that -2 is not included or excluded. 3 is included, and the shade the region between them. So how I can shade the region is simple. It means that I do have the line of numbers like previous, and I'm looking for that some kind of range over here. I'm looking for that specific range that's going to satisfy everything. So I do have this part, means that my x should be bigger than -2 or smaller than 3, while by knowing the fact that again -2 is excluded and 3 is included. So I'm going to start from here. After that, I'm going to finish up over here by knowing the fact that I have to some kind of shade everything between them, and this guy is open circle and this guy is closed circle itself. Let's see another example. So for another example, I do have my x that the condition should be bigger than 4 while knowing the fact that x also can be included by number 4 itself. So at this point, I do have number 4. Again, start with some kind of fill circle and shade whatever that I have. Since I don't know what is the positive infinite is, I just can write it down like this. As simple as that. So let's talk about the values that actually we care, and we are going to talk about it as much as possible. So what was the absolute value? Again, absolute means the distance of that specific number, would be any rational number or some kind of, right now we don't know anything about the irrational numbers because we are not going to open up that subject, but any number, any fraction that if you would like to find the distance between that specific point and 0, you can use the absolute value. So the very first thing about absolute value is the definition. It means that what is the distance from that specific number to 0 as a reference. For example, when we are talking about when we are talking about absolute of 3, we were talking about how many units or how many some kind of steps you should have in order to reach to the 0 as a reference itself. So it would be 3 as units. And also -3, same thing. That's why absolute of 3 and absolute of 3 is the same. And 0 is just 0 distance because it's a reference itself. So the key idea over here is that distance ignores the direction. Again, it doesn't matter that you have positive or negative. All the time, the distance is going to be something positive, so the sign doesn't matter over here. And also, it means that we do have the symmetry. It means that positive x equals, when we're talking about absolute numbers, is negative x. That we had it before, negative 3. So it is some kind of the fact that you don't have to memorize it, but it is something that there exists. So if you want to show it on the visual part, you can see that we do have the symmetry. It means that if I would like to find the distance of 3 and 0, I do have the absolute of 3. If I would like to find the distance between the negative 3 and reference itself, I do have absolute of negative 3, and both of them would be the same. So what would happen if I would like to find a distance between 2 points? Because on that side, we were only talking about 0 as the reference. So actually, that equate or some kind of that absolute expression was like this. It was 3 subtracted by 0. I'm trying to find the distance between number 3 and my reference 0, or it was negative 3 and 0. So it means that the second number is the number that you're going to find the distance, and the first number is going to be your reference. But at some point, your reference could be different. It means that instead of just having 0, you were trying to find the distance of that specific number and another number. So at that point, we are trying to find the distance between two numbers. For instance, when we are talking about the distance of a and b, the only thing that we have to do is find the absolute of that value, or absolute of b subtracted by a itself. For example, if I ask you what is the distance between 5 and 1, the only thing that you have to do is just subtract 5 by 1 itself. Maybe some of you would ask, so if someone say that the distance between 2 points, does it really actually have any different that if I find a subtracted by b or b subtracted by a? So again, we do have the symmetry over here. It doesn't matter if you find a distance from this point and this point, or from this point to this point. If everything is okay and you don't have any problem, both of them should be the same. Why? Because we know an absolute of positive number is the same. That's why we do have this rule, or we do have the symmetry property. It means that a subtracted by b, or absolute of that number, is equals to absolute of b subtracted by a. So again, if you would like to show this some kind of visualization part, the distance between the 5 and 1 would be something like that. 5 subtracted by 1 is 4. And if we would like to find the distance between negative 2 and 3, we have to some kind of do this one, and we do have it as 5, or this is the units for distance. So let's talk about the interesting part. So what would happen if I do have an equation, and after that I'm trying to find the answer, but at this point I do have absolute. So for the equations that we don't have any absolute value, or the linear equations, x plus b is equals to c, it is simple. We have to move all of the numbers in one side, move our variables in one side, in another side, and again try to isolate our variables. So I'm going to divide our variables by a specific number, because we're only looking for that specific value. We're not looking for 2x, 3x, negative 1x. We're looking for x. So everything was simple. But at this point, we do have absolute number, and we have to again remember a fact: the absolute number of positive and absolute number of negative is going to be the same itself. You don't have to be afraid of this solving the absolute number, because again, it has some kind of very simple step in order to do that. But one thing that you have to consider in your mind is that your equation is not going to have only one answer, but at this point is going to have two answers. So it means that when you have ax plus b is equals to c, you have to solve it for ax plus b is equals the actual c, which is the actual equation itself, and you have to solve it for ax plus b is equals to negative c. Why that's the case? Because when you're talking about a number inside absolute value, that number could be positive, that number could be negative. So we have to consider both of these conditions in order to make sure that our final answer is going to satisfy our specific expression, one equals to another, at any kind of condition. So let's talk about the steps. So the very first thing that we have to check is that when we're talking about ax plus b is equals to c, that number, that specific number, should be positive itself. So what does it actually mean? It means that whatever number that you have outside the absolute should be positive. It means that we don't have ax plus b, we don't have any kind of equation that absolute of ax plus b is equals to negative 3. It's completely nonsense. Because we know that whatever number that comes outside of the absolute, some kind of expression is going to be positive itself. So that's the very first thing we have to check. That's some kind of a fact. So after that, we have to isolate the absolute value. So if you remember for the equations, I told you that at this point, you have to isolate the absolute value. So it means that whatever that we have inside of it, could be anything, x plus b plus c, whatever you have over here, you have to isolate that at the end, after that part, you have to make sure that x plus b is equals to negative c. As I just told you, right now we do have two answers. So after that, everything is simple. It means that first of all, you have to solve this equation, find one of x value, and you have to solve this equation, another one. And also the final step, which is very important, I talked about it so many times, is that you have to check your answers, double check your answers, to make sure that when you find x1 and x2 as your final answer, put it inside the equation, and you have to still have this some kind of fact or this some kind of the main question itself. Everything should be satisfied. For instance, when we are talking about this answer, right now we don't have some kind of example, my bad. So this part is going to show you again why that -3 and 3 is going to be the same, and why we do have two actual values. So let's start this part with an example. Why not? So when we do have absolute of 2x minus 6 is equals to 8, so the first step, or some kind of the first authorization step, is going to be right. It means that my c value, this is ax plus b, instead of just having b, means that our b is -6, equals to c. So this guy is positive. So it means that this question is right. After that, I have to isolate some kind of absolute expression. So again, everything is isolated. There is no number beside that, so everything is okay. So right now, my 2x minus 6 should be equal to two things. 2x minus 6, first of all, is equals to 8. And after that, 2x minus 6 equals to -8. So we talked about it so much about how we can solve the equations. You can look at the previous videos, how we solve this one. 2x minus 6 is equals to 8. We have to move -6 to another side. Add everything by +6, so 2x is 14. Since I'm looking for only x, I have to divide both sides by the 2 itself. On another hand, I do have 2x minus 6 is equal to -8. So I have to add both sides by +6, so I do have 2x is -2 and x is -1. Right now, I have two answers. So how I can make sure that actually my answers are right? Easy. So I only think that I have to put this x is equal to 7 and -1 over here to see that actually this x for this equation is going to be right or not. For instance, for the first part, when we do have x as 7, means that 2 times 7 is going to be 14 subtracted by 6 is 8. So that's right. And also if I do have my x as -1, 2 times -1, -2 subtracted by 6 is going to be -8, which we know that absolute of -8 is going to be 8. So everything is okay. So sometimes if you would like to show that actually what are your variables, you're going to this format. So after that part, again, we are going to double check everything to make sure our final answer is right itself. So let's solve another example. At this point, we don't have the isolation by itself at the very beginning. So it means that we do have extra steps. So at this point, if I move this -5 over here, I do have both sides by 5 itself. So I do have 3 times absolute of x plus 4 equals to what? 6. By the way, when we are talking about a number beside of absolute, some kind of expression, again, we can consider that absolute of this part as another variable, for example, y. So whatever number that beside it could be written as the way it is. So the very first thing that we have to some kind of check, is it the answer of absolute expression or absolute part is positive? So we do have it as positive, so everything is okay. After that, we still have another step of isolation. We have to divide both sides by -3. So I do have my x plus 4 is equals to 2 itself. After that, we know x plus 4 equals to 2 and x plus 4 equals to -2. I will do this equation, and after that, find two answers for myself. The very first one is -2, another one is -6. So I have to make sure that the answer is right. It means that I have to put it inside this guy to make sure that everything is going to be satisfied. After that, I can say my answers are right itself. So what would happen if rather than just absolute number and equal sign, we do have inequalities? So this point is going to be a little bit more challenging, but still simple part. And it means that we still have to follow all of the steps, but with some kind of further steps. What does that mean? So when we are talking about inequalities, let me just show you an example. When we are talking about absolute of specific variable is smaller than another thing, we are talking about different aspect. What does that mean? Imagine that I do have a point, I do have a number, or I do have a variable that x should be, or absolute of x should be smaller. What does that mean? It means that whatever positive value for x that you have, that a specific positive number should be smaller than 2 itself. So I know for a fact one option for my answers is that x is smaller than 2. Another thing that I have to know is about negative numbers. What negative number can be fit in over here? For example, negative 1, negative 1.5, negative, I don't know, 0.2, whatever. So it means that right now, my negative numbers should be bigger than negative 2 itself. So the second option, x is bigger than negative 2. That's why when you have something in the question like this, x plus b is less than c, whatever number that you have on another side, or is equal less than or equals to c. So what you should consider two things: that your absolute value inside the absolute value is positive, and another thing that inside the absolute value is negative. So my x plus b at one point should be smaller than c and bigger than negative c. So right now I have to again isolate my variable, which is x over here, and do whatever I'm doing with this point, which means that subtracted by b divided by a in order to make x as isolated with 1, I have to do it with here and here. So it means that right now you do have an equation, but your equation actually has both two sides, because we are talking about the range of numbers. We are not only talking about one range, we are talking about two range of numbers. So right now, whatever that I'm doing, in order to make x isolated, I have to make sure that I'm doing it with negative side and positive side. Why? Because at the end, I'm trying to have my balance. I'm not trying to lose anything. It's just like the equation itself. You had one expression that contains your x, whatever variable that you have, and another part that you have numbers. As I just told you, whatever that you're doing with this side, you have to make sure that you're doing it with another side, because if you don't do that, you're going to lose your balance, and obviously your final answer is not going to be the right one itself. So again, we're talking about step by step, try to isolate whatever absolute value that you have. It doesn't matter what you have inside of it. Write this one like this. After that, solve all parts simultaneously. It means that whatever that you're doing, make sure to do it with all the three parts: 1, 2, and 3, and write the answer in interval notation itself. So let's talk about an example. X minus 3, by the way, absolute of x minus 3 is smaller than 2. So the very first thing that I have to know is that question is like this: absolute of x minus 3 is smaller than 2. As we all know, x plus b, when we are talking about the absolute number smaller than something, means that x minus 3 is between a range negative 2, which means a negative number, and positive 2 itself. So right now, as we all know, we have to make x as one isolated variable itself. So add positive 3, because I would like to get negative 3, positive 3 this side, but instead of just doing that on the right side, rather than just doing that on the right side, we also have to do it on the left side. So positive 3. At this point, I do have my x in the middle, I do have my 5, and after that, I do have my 1. It means that whatever variable some kind of range that I found, or if I use any x between these two numbers, this part or this section is going to be right. How we can check that? For instance, let's talk about x is equals to 3. So if I do it like that, x is equal to 3, 3 minus 3 is going to be 0, and 0 is absolutely smaller than 2, and that's how we solve. If you would like to visualize it, since we don't have some kind of including section or everything is excluded, this one is going to be like this. Simple as that. What about 2x plus 5 is smaller than or equal to 5? So everything is like the last part, but you have to be careful about this smaller than or equal thing, because last part we had excluded section, but this part we do have included section. It means that my 2x plus 5 could be smaller than or equal to 5 and could be bigger than or equal to negative 5. So be careful about that. So at this point, I do have 2x plus 5 is between two variables or between two sides. So first of all, I'm going to get rid of this 1, subtract with 1. So what do I have? I do have this. After that, I would like to get rid of 2. Divide everything by 2. Divide by 2. And at the end, we do have something like this. And this is the range of numbers. And this is the way that how we can visualize it. So what would happen if we do have greater than? So this point is going to be, again, another scenario. Let's talk about our famous example. It was x, this time is going to be bigger than 2. So again, we do have two conditions. The first condition is talking about the positive numbers. So obviously, when we are talking about the absolute of a variable that's going to be bigger than 2, the very first thing that we reach to our mind is 3, 4, whatever positive numbers. So x should be bigger than 2. It's simple. But the second thing is about the negative number. What is the variable that actually, if we put there, is going to be bigger than 2? Obviously, it's a negative one, right? But what is the range? That range should be whatever variable that is going to be smaller than negative 2. What does it mean by smaller? So if you, I guess I talked about it, but again, when we are talking about negative values, when we are talking about something is smaller than another thing, actually we are talking about vice versa in positive section. Because in positive part, when I tell you that 3 is bigger than 2, you would say that makes sense. But in the negative side, when we say that negative 3 is bigger than negative 2, it doesn't make any sense. Why? Because negative 2 is closer to 0 rather than negative 3 itself. That's why negative 3 on negative side is going to be smaller than negative 2. So when we were talking about this equation, this inequality actually, when x is bigger than 2, absolute of x is bigger than 2, x either should be bigger than 2 itself, when we are talking about positive part, or x should be smaller than negative 2 when we are talking about the negative side itself. And this is the way that we are going to use in order to solve this inequality itself in order to find the range. It means that when I do have ax plus b is bigger than c, I have to consider, again, this part is going to be another condition that when you include a number, it means that this is excluded and this is included. So at this point, the very first thing that I have to know is that x plus b either is bigger than c or smaller than negative c itself. For instance, I do have 3 times x plus 2, negative 1 subtracted, so subtracted by 1 is bigger than 8. So it means that if I isolate everything, because the very first thing that I have to isolate it, right? So it's somehow like the previous part, but with extra steps. I do have x plus 2 bigger than 3. So at this point, I know x plus 2 either is bigger than 3 itself, that's a fact, or x plus 2 is smaller than negative 3. Again, solve this one and you do have your final answer itself. So let's talk about an example. X plus 2 is bigger than or equal to number 3. When we do have bigger than equal, it means that my 3 is going to be included. So x plus 2 either is bigger than or equal to 3, or x plus 2 is smaller than or equal to negative 3. Solve this one and you have your final number. How? X plus 2 is bigger than 3, right? So subtract it by 2. This is the first answer, and this is the second answer. X plus 2 is smaller than negative 3, negative 2, negative 2, because we would like to get rid of 2 itself. So x is going to be smaller than or equal to negative 5 itself. How we can show that? Simple. At this point, rather than just one range, we do have 2 range. Either my x should be bigger than or equal to 1 in order to satisfy this some kind of inequality, or it should be smaller than negative 5 itself. So I do have 2 range. It would start from 1 to positive infinite. It would start from negative 5 to negative infinite itself. So let's see another example related to this one. So for this example, I do have 4 times absolute of 3x minus 2 is bigger than 10. Since we do have bigger than condition, it means that my variable or my whatever is inside that absolute part is going to be bigger than it. Something positive is going to be smaller than something negative. So the very first thing that we have to do is make this part or this section isolated by divide everything by 4. So if you do that, we do have something like this. Again, remember, it is excluded. It means that my number cannot be bigger than, cannot be equal to 10 itself. So I do have 3x minus 2, absolute, is bigger than 2.5. Either 3x minus 2 is bigger than 2.5 or it's going to be smaller than negative 2.5. If we just do the calculation, you do have something like this, and at the end, something like that. It means that you do have 2 range, and if you would like to visualize it, it would be like this. The very important thing related to these subjects or any other kind of related subject that you have is that whenever you first see a question, it's going to be a little bit challenging for you, that I completely agree with that, because it is new. So you do have some kind of unintentional resistance inside your brain that this question is impossible. So let's see the answer. I would like you guys to fight that resistance, pause the video, don't look at the answer on the screen itself, try to solve it by yourself. Again, this is going to be your very beginning part. You don't have to solve it right now, because if you solve something, you obviously don't need any kind of teaching from YouTube, even your teacher. So try to some kind of do it as much as you can, and at the end try to find the answer yourself, because sometimes you do it, you see the answer and you still don't understand anything. So it means that you have to do it yourself, no clue, see the answer, some clue, and again read back or rewatch it again to have all of the clues, and at the end solve it by yourself, because you would like to make sure that for the next time when you do have different example, how you can solve it. And that is the very important part of watching this kind of videos itself. So let's talk about applications. So we talked about it right now that we found a variable, so how we can use it. If you guys remember, when we were talking about the real world application, we were talking something related to tolerance. It means that, for instance, when you put your thermostat, and you do have a thermostat, and you would like to put a temperature on the specific point, for example, 72 Fahrenheit degrees. Obviously, you do have some kind of inaccuracy. It doesn't necessarily mean that the whole room is going to be 72 at that specific point. You do have some errors. It means that you would say to your thermostat that if you can keep the 72 between 70 and 74, I'm satisfied. So at this point, we are using inequalities. We are using absolute concept, and we can actually apply it to our appliances, to everything. So at this point, when we're talking about tolerance, I do have my X, for example, it could be the temperature of the room itself. I do have the target, and that target, for instance, this temperature is something that I don't know right now. The target was 70 degrees, and I do have a tolerance, and I would tell that if you do have positive 2, obviously when we're talking about absolute value on the right side, the answer is positive. Your tolerance is smaller than 2, means that it's going to be between 68 and 72, I'm happy. So this number is not only going to be one thing at a time. Obviously, it's going to be one thing at a time. But this something at the end, the error or the difference of that specific number and that point, which is going to be my reference, which is a 70, at all the time should be smaller than .2, which is related to absolute, related to tolerance, and related to everything that we just learned itself. So for instance, again, we were talking about the temperature control. I would like to have the thermostat and must maintain this temperature at 72 degrees by knowing the fact that the tolerance could be negative to itself. Maybe for some of you it would be a little bit confusing that why we're talking about positive 2 and negative 2, because if you guys remember, when we do have absolute and we do have inequality and we do have equations, why we do have absolute, we're going to have two answers. Either my right side can be positive or negative. It is going to be completely different with this fact that the right side of absolute value should be positive. It is another story. The thing that I'm talking about is the number inside the absolute. For instance, when you have x, absolute of x is smaller than 2, x could be between negative 2 and 2. I'm not talking about the right side. The right side is positive all the time. The right side is going to give me a clue about whatever that I have inside should be at what range. So that don't get confused. So I do have a tolerance itself. Again, if I do have something like this, means that if I know, or if my thermostat knows, that the temperature is going to be between 70 and 74, I'm good itself. About some kind of manufacturing precision. It means that the machine part must have radius of 10 millimeter with tolerance of positive negative 0.02. So again, we are going to solve this part, and I do have the range itself. At everything, I do have range. So the summary. So we were talking about absolute numbers. First of all, we were talking about the numbers itself. Which one contains what part of numbers and which one is going to be underneath of one part. It means that at some points we do have one category contains different kind of things. After that, we are talking about interval notations. At some point we do have a range of numbers, and also we do have excluding and including. We were talking about the absolute value, which means that the distance between one specific point and 0. Most of the time we are talking about that specific point and 0. But at some points we are talking about the distance between 2 points. So remember, it's going to be two different conditions. We were talking about the equation, absolute of x plus b is equals to c. And you remember, ax plus b itself is going to be equal to c and equals to negative c. It is important. We had the less than condition, and we saw some examples, and we understood how we can solve them, and after that we had greater than thing. So for your quick practice, you can solve some kind of question that I put for you over here, and if you would like, it would be fantastic if you can comment it on the comment section for other people in order to see what your final answer is going to be. And not only you're going to practice yourself, but also going to help others that how you can find the final answer itself. Thank you very much for being here with me. My name is Mahmoud Kiasari, and if you would like that, I would be appreciated if you like, share, and comment. That would be so helpful for me. Have yourself a great day, night, whatever. See you around.